Okay, different styles of fog and cloud. One common type of fog, the most familiar one if you're not near a body of water, is the fog that we get if the night has been, again, relatively clear, so heat is lost out into space easily. Cool, lower temperature, and calm, not much wind, so air in one place can settle down and cool off rather than getting mixed with slightly warmer air around. And of course, we need to have a relative humidity that's high, reaches 100%. Often this will be in lower lying areas where cooler air has sunk down and cools off enough to reach the dew point, and we get the fog. On a foggy morning, you see this, say if you're driving on the road, you're at the top of the hill, things look clear, and then down the side of the hill, and all of a sudden it's all foggy as you get down into the cloudy area again. You also get fog that forms around water bodies. If we've got a large body of water, say ocean or maybe a large lake, and it's cool, we can get, of course, there's plenty of water to evaporate, so the air above the water is typically quite high relative humidity. And with that cooling down, we can get fog forming over the water. Wind may move it around so that it drifts over the land, making the land foggy as well. Small fog can occur above a very moist surface where there's evaporation into cool air. This can be seen over melting snow. Around here, it's probably most often seen right after a rainstorm, where we have very moist pavement, like the parking lot here. And yeah, it's a little tricky to see, but there are wisps of fog rising up off the parking lot, or say over a body of water. This is a fairly small temporary fog. Again, we're getting a lot of water vapor and cool air, and the combination leads to this foggy appearance. How about clouds? Of course, people have looked at clouds for a long time, but the first attempt to give kind of a scientific division into categories that's stuck through to our modern ones was first done a little over 200 years ago in England. And of course, back then, Latin's kind of the scientific language. So his major cloud categories are based on Latin terms. Cirrus meaning curly. They often kind of hair-like, wispy, stringy clouds. Cumulus meaning piled up, kind of lumpy, fluffy clouds. And stratus meaning a layer, so clouds that are spread out, forming layered patterns. So these three basic types are major categories of clouds. Yeah, you can get a lot more specific. There are lots of variations within these. So today we have 10 official classes of clouds. We'll just focus on these, but knowing more exist. Cloud shape, and also how high up they are. Altitude is also important. Okay, how high up is that cloud? Well, I think it's about 10 feet. How do we know just how high our cloud is? Well, that can be a little tricky, but we can get an idea of looking up and that cloud is higher than that cloud, so we can get relative things. Also, conveniently, it turns out that clouds at different heights do tend to look different. So just by looking at them, at the shape, we can tell something of which type of cloud we're looking at. We don't have to have some way of directly measuring the height in order to give it its category. So here are examples of some of the common major types of clouds. Are cirrus clouds, relatively hair-like, kind of wispy, or cotton candy look to them. Stratus, relatively layers, although it's a little tricky to see the pattern. We should see more of a layer to it, but it kind of goes off the picture. Cumulus, puffy, lumpy clouds, kind of piled up looking. We have some variations here. If we've got kind of lumpy, but kind of hair-like as well, those are cirrocumulus. Cirro referring to high level. It turns out that cirrus clouds are high elevation clouds. And that kind of hair-like, stringy, wispy look to them is because they are made of ice crystals. Typically kind of needle-shaped ice crystals. And that gives them their distinctive form. Mid-elevation, those are referred to as alto cumulus or alto stratus, like alto being a somewhat mid-level voice in singing. And then just plain old stratus and cumulus are lower level clouds. We can also have, well, it's kind of puffy and kind of layery for stratocumulus. One other thing in names, nimbo refers to that it is raining or snowing on us. So a nimbostratus cloud is a layer of cloud that is raining. Cumulonimbus, why they stick it after from one and before the other, don't know, but we're stuck with it. Cumulonimbus is a puffy cloud that is raining or snowing, and sometimes thundering as well. Now there's lots more. There's special types of clouds. You can get into quite a lot of detail if you're interested. Just a couple years back, the official International Cloud Atlas was revised to give you all sorts of categories, and it even talks about stuff like rainbows and whatnot that aren't really clouds, but they're in the air, so it covers those too. Different types of clouds go with different weather. Cumulonimbus typically gives us heavier rain, but not as long lasting, like a thunderstorm. Stratus clouds tend to be longer but lighter rain or snow. Cirrus clouds do not make rain or snow. They're too sparse, just ice crystals way up there. Stuff is going to demand to fall down all the way to the surface from those. Some other cloud shapes give us important information about the weather. A twisting funnel, that's very important to know if that's in your local weather. Or a large hurricane. Of course, this is part of the overall water cycle. We've looked at it plenty before with the oceans. Water is evaporating, especially from the ocean, because that's a lot of water, and then moves around in the air for a while, condenses, we get precipitation, and flows down back to the ocean once more, the hydrologic or water cycle. Water residence time in the air is on the order of several weeks. So that means, again, residence time that typically when one molecule of water evaporates, it's floating around in the air for several weeks before it condenses down and is back to the surface. Again, that's an average. One particular molecule might evaporate and condense right back again. Another might spend years floating around before that particular one happens to condense. But the average is on the order of several weeks. Any one bit of the ocean, on average, evaporates about 97 centimeters worth of water. Of course, that's more in warm areas, less in cold areas. But 97 is about the average, so not quite a meter. The amount of rain and or snow falling on a bit of the ocean is about 90 centimeters. That remaining 7 is what's going into the air and moving over land and providing our rain and snow up on land. Now, if for some silly reason we decide to build a great big wall around the edge of all the land and trap all that water on the land rather than letting it go back to the ocean. Then each year, the ocean will be 7 centimeters lower, and more is trapped on land, and eventually you'd evaporate all the oceans and have all that water on land. I don't know why you'd want to do it, but illustrates the principle of the water cycle. Okay, so making a cloud, we need for air somewhere above the Earth's surface to cool down and reach the dew point. Why would air cool down? Usually because it's gone up. Again, down here in the troposphere, temperatures typically, troposphere, it's mixing around, it varies, but typically temperatures are dropping as you go up. One common reason is convection. Different places are warmer or cooler. Some place where things get warmer, maybe the surface has a bit lower albedo, and that warms up more. The air above it gets warmer. That air is relatively warmer, expands, rises. Other air, relatively cooler, sinks. So, we see, or particularly air, so it's a little tricky to actually see it, but we have air rising. This is taken advantage of, say, by our local vultures. They can glide and ride that rising warm air, thermals. So we have warm air rising, along with our rising vulture. And as this air rises, other air will move in from the sides to take its place. You can see this effect of the settings. For example, if you have a lighter weight shower curtain, if it's cool in the room and you turn on hot water inside the shower, air inside the shower is going to get hotter, tend to rise. Cooler air outside will tend to move in to replace it, and the curtains will tend to billow in towards the inside of the shower. Another way we can lift air is if air runs into a mountain. The air went over the mountain, well, it can't go through. So as it goes up, it's going to cool down, and we're likely to form clouds, maybe even have rain or snow as that air rises up to go over the mountain.